use the second derivatives test to determine the nature of the function f of xy equals 2 minus x to the fourth plus 2x squared minus y squared at its critical points. So first we have to find the critical points, and then we have to determine if they are local min, local max, or saddle point. So f sub x, partial derivative with respect to x, 0, negative 4x cubed, 4x, 0. So this is f sub x. Set that equal to 0. At a critical point, f sub x and f sub y are both 0. So this is going to give us x values of the critical points. And let's look at f sub y. 0, 0, 0, negative 2y. Negative 2y equals 0. Well, that's very simple. That means that the y coordinate at a critical point must be 0. And now let's solve the f sub x equals 0 equation. X equals 0 is one solution. And then if x isn't 0, we could divide it out. And we get negative 4x squared plus 4 is equal to 0. We could divide out the negative 4. And that's x squared minus 1 equals 0. So x equals plus or minus 1. So there are 3 critical points. At all 3 critical points, the y coordinate is 0, and the x coordinate is 0, 1, or negative 1. So we have negative 1, 0, 0, 0, and 1, 0. These are the critical points. And then we have to calculate the discriminant. D of xy is f sub xx times f sub yy minus the square of f sub xy. That should be a minus. So f sub xx is negative 12x squared plus 4, and f sub yy is negative 2. And the mixed second derivative, f sub xy, is 0. So our discriminant, this part is 0. We just multiply these together, and we get 24x squared minus 8. And now we plug these points into this expression. So the discriminant at the point 0, 0, say, is negative 8. We're plugging in x equals 0 and y equals 0. There's no y in the discriminant, so we're just plugging in x equals 0, and we get negative 8. That's obviously less than 0, and that means that we have a saddle point at the origin at 0, 0. And when we plug in negative 1, 0 or 1, 0, we get the same thing, because with the x squared we get 24 minus 8, which is 16, and that's bigger than 0, and that tells us that we have a local extreme of some sort. And to determine the local extreme, we look at f sub xx or f sub yy. F sub xx at the point negative 1, 0 is negative 12 plus 4 is negative 8. That's negative, and that, so we can think of that as concave down. So that means that we have a local extreme is a local max at negative 1, 0. And we're going to have the same thing at the other critical number 1, 0, because whether we plug in 1 or negative 1 here, we get the same thing. F sub xx at 1, 0 is also negative 8. So we have a local max here as well. So we have a local max at 1, 0, negative 1, 0, and we have a saddle point at 0, 0.